This video is about two things we're going to study in this class to start our motion unit: displacement and distance. So, distance is the total length an object has moved or traveled. So, an important thing to remember about distance is that the length that the object moves or travels does not have to be in a straight line, and it does not have to be in a specific direction. For example, if I go from point A here to point A to point D, and then I go to point B, even though point A and point B are only 10 meters apart, I will have traveled a farther distance because I took this curved path. Maybe it's something like 15 meters long. Okay? And because it doesn't have to be a specific direction, I could go, for example, from point A back to point B, and it will be a distance of 10 meters. Or I could go from point B to point C, and it will be a distance of 10 meters also. So it can be in any direction that you have movement, that you can have a distance. Oops. Displacement, on the other hand, is different than distance. Displacement requires that you think about the shortest distance between the starting point and the ending point. This does not include the distance to the points in between, like we talked about before, where we went to point D. It must be a straight line, and it must be in a specific direction. For example, if I go from point A to point D to point B, like I did before, we said that was 15 meters in distance, I will have only gone a displacement of 10 meters. And my displacement will be the distance straight from A to B, 10 meters. And it'll be in a specific direction, so I'll say 10 meters to the right in this case. Okay? If we use the example that we used before, where we go from point B back to point A, and we said that was a distance of 10 meters, and we go from point B to point C, as we did before, that would be a distance of 10 meters. But if we look at displacement, this would be a displacement of 10 meters left, and this would be a displacement of 10 meters right. Okay? So the displacement is dependent on direction. So even though we have the same amount of distance, 10 meters and 10 meters, because we have a different direction, left and right, we have a different displacement. So it's very important that we think about the direction when we think about displacement. Because we think about directions, we might need to learn what the compass directions are. So a good way to remember what the compass directions are to remember the acronym never eat soggy waffles. Okay? Never eat soggy waffles. So never, N, start at the top. We go clockwise around right, E for east. So we have north, east, south, soggy, and waffles, west. Okay? You can also remember this by saying, oh, east is E, so I eat with my right hand. In between the compass directions, we have intermediate compass directions, like north, east is in between north and east. South, east is in between south and east. South, west is in between south and west. And north, west is in between north and west. So those are something to remember. Both distance and displacement are measured in the same units. And the units that distance and displacement are both measured in are called meters. And we show them with a little m, lowercase m. Sometimes we make large measurements, and so we need to measure something using lots of meters. In this case, we would use kilometers, which is the equivalent of 1,000 meters. So the distances in between cities or very large areas we would measure in kilometers. We'd measure smaller things that are smaller than a meter in fractions of a meter. Things like centimeters or millimeters. And we'll get into that more as we go into this class.